Well, hello again everybody, and welcome back to my humble little channel. And look what I've just bought. It's a Marconi 2022C signal generator. And why I bought this, I do not know. After all, I've already got one up there, which I've had for I think 20 years now, and spent many happy hours repairing it, and now it's been working reliably for at least 10 years. But back to this one and why I bought it. It's well, it was, call it one of those drunken late night purchases on eBay. He wanted $350 for it, buy it now, or best offer. So I offered him roughly half that, and after a bit of negotiation I came up a little bit and he accepted it. So I got it for just over half the price he wanted, so I just couldn't really resist it at that price. And the other reason I bought it, although it's not really significant, is that the one I've got previously is the 202E version, which is the more common version, which goes up to 10 dBm. Now this one, for some strange reason, goes up to 13 dBm, and I think they do a version that only goes to 7 dBm, which is rather strange. So I've got twice as much power, which is not going to make much difference to my life, but I couldn't resist it at the price it was, and assuming it's all fine and working, I will probably sell my other one and keep this one. So let's turn it on, and I already have, although it's only just come, and it does work as far as I can tell. So it's coming up with its default setting of 1000 megahertz frequency, and the power level is -127 dBm. That's the lowest it will go. But there's an option in it to set it to turn on at memory 10, which is what I've done with my old generator, because I don't want it to come on at 1000 megahertz particularly. So I should probably go into the menu later on and change all that. First impressions of it are, it's a bit dirty. I won't show the top for the time being. It's not too bad a condition considering probably how old it is, but the main problem it has got, and to a degree my old one suffers from the same problem, is the display on the bottom. You probably can't see it, but some of these digits are slightly faded, and if you touch on it they get improved. It improves the contrast. It's the same on the modulation setting, but I don't think it's much worse than my other one. That's also got a similar problem, so I'm not too concerned about it. It's readable. It's perfectly readable. And if you want to see a proper review of one of these, there's a guy in Italy called Diego, and his channel name is IZ0MTW. He's done over an hour's video on one of these, and we've been in communications about this particular signal generator over the last few weeks. Well, he's got the E version, but this is the C version obviously. So I've got a long history with these generators. Back in the late 80s, when I was working for a certain government establishment that shall remain nameless, in my particular department we were given a budget of £20,000 to spend on test equipment. Well, £20,000 doesn't really go far when you want to buy a few pieces of test equipment. I think we needed a couple of oscilloscopes, an RF signal generator and a spectrum analyzer, apart from maybe the odd multimeter as well. So it was my job to go and find fairly low cost pieces of equipment. So I went to the technical library, and Hewlett Packard were out of the question. You could spend 20,000 on a signal generator, let alone the rest of the stuff we needed. But Marconi had just brought this one out, and it was priced at £6,500, which was just about affordable, considering I had to buy a spectrum analyzer as well. And the spectrum analyzer I chose was a Takeda Raikin, Japanese, and it was £6,500 also, I think. So I chose this signal generator, and it worked well at the time. But sorry for going on a bit, but the problem with these signal generators is that they have a known issue. They have like a thick film ceramic dipped package in them, which consists of a transistor and a few resistors. Basically it was a early version of a MMIC, monolithic microwave integrated circuit, and they were like a gain block, a 12 dB gain module. Looked like a tiny little, well, fairly small chip, about an inch long, and they had 12 dB gain roughly, and they had a broadband frequency response from, I don't know, a megahertz maybe up to a gigahertz, and they were designed for the cable TV industry, and they had 75 ohm input and output impedance. But the problem with these was, and I found out with my old generator, that one by one they all go faulty, these little devices called an OM345, which were designed by Philips. They eventually all die. So that's why I spent many happy hours replacing them all in my my other one, and there's I think 7 of them in the generator. So I replaced them with a modern device which is much more reliable, either by Avantec or Mini Circuits, I can't remember which, but that's just one of the problems that is associated with one of these generators. And later on I shall take this apart and see what's in it, and see if they have replaced, or anybody has replaced, the OM345s in this one. But maybe they brought out a more reliable version later on, but I don't remember, I don't know anything about that. But anyway, back to this one. We'll just do a few tests on it, and as I said, it's come up at its default of 1000 megahertz. I don't really want to go to those extremes at the moment, but I'll set it to 10 megahertz. We've got obviously carrier function. It's set the carrier frequency at the moment, so I set 10, then megahertz. And now the power level's set to 127 dBm. But if I go over to the spectrum analyzer, obviously we're not going to see a lot at that level, so I changed the power level to 0 dBm and press peak. Well, it says exactly 0 dBm, so you can't say much better than that, can you? And I can increment that in 1 dB steps, and we're up to 5 dBm, 10 dBm, 9.91, pretty bloody close really. And of course I can go up a bit higher in this one model, got to 13 dBm, so that is all fine. And I could, I suppose, look at the harmonic content if I change my frequency range. If I press stop frequency of 100 megahertz. And as we can see, we have got some harmonics, but let me reduce that a bit, power level to 10 dBm. So in relation to 10 dBm, the worst harmonic is 10, 20, 30, over 40 dBs down, which is, I think, within its specifications. I think the specifications are minus 25 dBm. something like that. But we can also look at the subharmonics, but I'd rather do that at a higher frequency. So if I set the frequency now to 100 megahertz, and frequency range, start frequency, I set start frequency to 0, and ignore that one there, that's the 0 marker, if you want to call it that, and stop frequency, say 500. So now we can see there are no subharmonics at this particular frequency, and we can see all the other harmonics. If I change the frequency to say 250 megahertz, I'm still getting no subharmonics, and let's try stop frequency of a gigahertz. So now we can see the spectral content at 250 megahertz, and again we're at least over 30 dBs down on the second harmonic, which is really pretty good, I think. I can go up again to say 500 megahertz, and I change my start frequency to say 100. No, maybe 400. And stop frequency, I'll go to 2 gigahertz just because I can. And now we can see the spectral content there, and we're still within specifications. I think that's the third harmonic peak. Right peak. No, that's the second harmonic, and that is the minus 18 dBm, so that's still pretty good, and that's a spurious signal, I think. Yeah, it is coming from the generator, because this spectrum analyzer does have a few sproggies of its own that it generates. So what else can I do with it? I mean, I could do peak again, peak to CF, and expand the span. If I go to a really narrow span, peak to CF, we can see, I guess you call it phase noise. It's not a particularly clean synthesizer compared to a more modern piece of equipment. What am I on there? 2 megahertz. I want to expand that even more. So there we are, it's at 500 megahertz, and we got 10 dBm going in, and if I drop the power level down, I go down in 10 dB steps. In order to see down at that level, you need to decrease your span and increase your amplitude or reference level. So that's minus 60, and that's what it says on the generator, which is perfect. I can go a lot lower, of course. I can go down to minus 80, minus 90, minus 100. Now we're struggling, but I can get around that by setting on my attenuator 0 dB attenuation, and I can still see the signal at 100, minus 100. This is more a test of the spectrum analyzer than the signal generator, but I can get even better resolution than that, and I can turn the preamp on, and there we are. It makes a difference, doesn't it? And I can drop the power again to minus 110, press peak, and again to minus 120. So that's about the limits really of the spectrum analyzer. I can clean the signal up, but there's not a lot of point really. Could change the bandwidth, amplitude, I can clean it up a bit more, bandwidth, but you know, that's down 127 dBm, so yeah, that's working fine. I think what I'd like to do though is check its frequency accuracy. So back to this thing, as you can see it's on 500 megahertz minus 120 dBm. So what I'll do is I'll go to carrier frequency of 10 megahertz and RF level 0 dBm, and I haven't even started talking about modulation, but we won't worry about that at the moment. And I will now connect to my my frequency counter, Hewlett Packard, and for some reason it's not reading anything. Okay, dodgy connection on the end socket. Okay, well, bear in mind this has been turned on, the signal generator's been turned on for roughly an hour. Trying to get this thing to stop moving around. Right, that's more stable. Okay, so the signal generator's been on an hour, and so it's had plenty of time to warm up. It's only a free running crystal oscillator in the generator, so it's nothing special, no OCXOs or anything like that. And what we can see is, and this device is got, or what it should have, it has now. No, I should get an external standard enabled, but I'm not sure about that, why it's not enabling the external standard into the back from a GPSDO, but forget that for the time being. I know this generator is very, very close to having a perfect 10 megahertz oscillator in it. So as I was saying, we can see that it's got roughly a 3 hertz error. I think that's pretty close. I could adjust it, but there's really no point. That's pretty impressive, really, for a simple crystal oscillator. So I'm not worried about that. That doesn't need adjusting. There's only a simple trimmer on the back to adjust the internal oscillator. So that's about it for this part, but I think this one was on eBay for some time, and I think the reason people it didn't sell is because it had this on it. No, forget that. It had this on it, error 11, which he was good enough to show in the photograph, one of the photographs. And unless you look closely, you don't realise what error 11 is. It basically means it's been set to have an external frequency reference put into it at whatever frequency it is. It can be, I think, 10 megahertz and maybe 2.5 megahertz, depending what you select. But anyway, that's all that error 11 means. It's not a serious problem. As if you can look close, you can see it says external standard. Well, it's basically telling you that there is no external standard plugged in. So all you have to do is just press the internal external button, and that is sets it to work properly again, obviously. So I don't want to make this too long a video, because Diego's already done that, an hour and a quarter. I could go into the modulation settings. It's got FM, which goes between 3 kilohertz and I think a megahertz, depending on the frequency you've got set. So, and of course you've got AM, which goes between 0% and 99.5%. Apart from that, I would like to take it apart and have a look inside it and see what, if anything, has been done to it to change the OM345s. So I may do that next. You could do with a clean up as well. You could have a quick look at the case and what state it's in. Okay, well, I found out what was going on with the counter. As you can see now, I've got external reference, which comes from my GPSDO. So I went around the back of the counter, which is not easy, because you have to climb up on the bench. For some reason I had the output from the GPSDO plugged into the output from the counter, 10 megahertz output, instead of the input. I don't know how the hell that happened, but as you can see, it's made virtually no difference. The signal generator is still more or less the same frequency, because I know that the oscillator in this is very, very close to 10 megahertz in the first place, just a few millihertz out. There's enough of that rubbish. It was just when I find something weird like that, I need to know why it wasn't working properly. And if I just flick the switch, you see external reference should go off. Well, it's basically, you have to reset it. Where's run? I can't see. Run. Yeah, it goes back to its internal time base now, and the external reference symbol goes away. So that's sorted that one out. Now let's just take a look at this generator. I could look at the amplitude, the modulation quickly, maybe. Right, where was I? I'm not sure where I was, but I'm going to stick the signal into a scope. And what do we get? Nothing. Okay, it's dodgy end plug. Let's have a look at that end plug then. Doesn't look much wrong with it. It's not damaged, just not making very good contact. Oh well. Back to this stuff. So that's your 10 megahertz carrier with no modulation. If I go to AM, I put say 30% into it. There we are, we've got some modulation. And it's always difficult to trigger properly, but I can go increase the modulation. As you can see, it's working. I'll go up to 100%. There we are, that's as good as it gets, which is more what you expect really. So the AM works fine. I'm sure the FM does too. I could just check the FM. Okay, we're going to check the FM on the spectrum analyzer. So I'm 100 megahertz with no modulation at the moment. So I just turn on FM and we're 3 kilohertz modulation. So that looks good. I can increase that 4 kilohertz. 5, 10 kilohertz, that's fine. I can see that's working fine. That's all I need to do on that. And do you know what I've noticed though? There's something missing. If I look at my other one up there, you see it's got 3 little LEDs. You can see that. And that changes the tone of the modulation. 1 kHz is the default, and you can go up to 5 kHz, down to 400 Hz. I don't just notice that on this one, no LEDs. For some strange reason, they decided that this one would only have 1 kHz. I don't think it's a major issue. I mean, if you really want to, you can stick a different frequency into it, which is fine. But anyway, enough of all that. I need to just check it over and see what state the case is in. So the top panel looks fine, no dents, no scratches really, a bit dirty, now I'll clean off. The bottom is more or less the same, couple of scratches, nothing serious. We can look around the back of it. And it's the wrong way up. Right, so that's the back panel, and can't see any problems with that. Doesn't say when it was calibrated last. Do not remove. Oh well. Yeah, everything looks fine. You've got another modulation input there as well as the one on the front panel, and that's your external 10 MHz reference input, and that's for adjusting the internal oscillator. So that's it really. The only thing to do really, I think, is to take it apart and have a quick look inside. So I took it all apart just because I was curious about the devices I was talking about earlier, the OM345s, which are these things in ceramic packages. And strangely, it looks like they're all here still. So whether they had a bad batch of them or not, I don't know. But if I look at the date codes on the chip, that's 8705. So it's roughly the same age as my others, 2022. And there's loads of these OM345s. There's 1, 2, 3, 4. I can see 4 at least, and I know there's some more underneath this can here. I think there's 7 altogether. And there's another one, there's an OM360. That's got roughly twice as much gain in it compared to the OM345s. So that's about it really. That's all I'm going to do on this now. But if you're interested in about all the functions of this generator, please check out Diego's channel, and I'll try and leave a link to the video he did on this, or the signal generator he's got. So all I need to do now is just put it all back together and clean it up a bit, then I'll probably sell my other one. So that's it for now. Bye for now.